Hey folks, in this section you're going to learn some more identities. We start off by looking at the product to sum identities, and then there's some identities called the sum to product identities. I've written over here what the product to sum identities are, and well, those are the four that are called the product to sum identities. And these are not identities you need to commit to memory. It's just more of this section and the examples I'm going to do is going to be more of if you can just use an identity. Keep in mind identities, I've been stressing identities that you need to know, you need to commit to memory. These do not need to be committed to memory. So let's look at this first example. I have here as an example, write the product as a sum or difference containing only sines and cosines. And this is the product, sine 7 theta, cosine 3 theta. So I look at my product to sum identities and I say, well, which one does it look like? Sine 7 theta, cosine 3 theta. It's a sine times a cosine. So I scan my list to look for a sine times a cosine. It looks like it's this identity here, sine A, cosine B equals that mess. So this is the identity that I'm going to use. So since I'm going to use it, let me just write it down. Sine A cosine B is 1/2 sine A plus B plus the sine of A minus B. So that's the identity I'm going to use. And now I'll just say, well, the sine of 7 theta cosine 3 theta, it looks like in my identity, 7 theta is in place of A, 3 theta is in place of B. So wherever I see an A here, I'm going to put a 7 theta. Wherever I see a B, I'm going to put a 3 theta. So that gives me 1/2 the sine of 7 theta plus 3 theta plus the sine of 7 theta minus 3 theta. And now if I just kind of clean this up, I get 1/2 times the sine 7 theta plus 3 theta is 10 theta. So 10 theta plus the sine of 4 theta. And then if you want, you can go ahead and distribute the 1/2 to get 1/2 sine 10 theta plus 1/2 sine 4 theta. All right, hey folks, for the next example, I decided to leave the product to sum identities up here, on the board. The next example is determine the exact value of cosine 5 pi over 8 times cosine 3 pi over 8. So this is a cosine times a cosine. So I look at my product to sum identities for a cosine times a cosine. It's this one right here. So it looks like this is the identity that I will use for this problem. So let me just write the identity down. Cosine A times cosine B equals 1/2 cosine A minus B plus cosine A plus B. Well, looks like, and if I just write this down here below it, cosine 5 pi over 8 times cosine 3 pi over 8, it looks like 5 pi over 8 is in place of A, and 3 pi over 8 is in place of B. So wherever I see an A, I'll put a 5 pi over 8, and wherever I see a B, I'll put 3 pi over 8. So that gives me a 1/2 cosine 5 pi over 8 minus 3 pi over 8 plus cosine 5 pi over 8 plus 3 pi over 8. And continuing on, let's see here, 5 pi over 8 minus 3 pi over 8, that's 2 pi over 8. 2 pi over 8 reduces to pi over 4. So pi over 4. And here we have a 5 pi over 8 plus a 3 pi over 8. That would give me 8 pi over 8, which reduces to pi. And now just using our knowledge of the unit circle, cosine of pi over 4 is square root 2 over 2. Cosine of pi is -1. And if I go ahead and distribute the 1/2 on through, I get square root 2 over 4 minus 1/2 as being the exact value of cosine 5 pi over 8 times cosine 3 pi over 8. And that's it for that example. All right, next up is a look at the sum to product identities. Here they are. Those are the 4. Just like the product to sum identities, you do not have to commit these to memory. We're just going to see if we can just learn how to use these identities. So here, for example, first example I have here is to write the sum as a product containing only sines and or cosines. And we're given the sum sine 11 theta plus sine 9 theta. So when I'm given that sum and I want to write it as a product, I look at my sum to product identities and I'm looking for the one that would involve 2 sines, a sine plus a sine. And it's the very first one. So I'm going to use this identity. So let me write it down. It's sine A plus sine B equals 2 times the sine of A plus B over 2 times the cosine of A minus B over 2. So now when I look at my sine of 11 theta plus the sine of 9 theta, it looks like A is 11 theta, B is 9 theta. So wherever I see an A, I'll put in 11 theta. Wherever I see a B, I'm going to put in 9 theta. So this gives me 2 times the sine of 11 theta plus 9 theta over 2, cosine of 11 theta minus 9 theta over 2. And cleaning this up, let's see, we would have 11 theta plus 9 theta. Well, 11 theta plus a 9 theta is 20 theta. 20 theta divided by 2, well, 20 divided by 2 is 10 theta. And 11 theta minus 9 theta is 2 theta. 2 theta divided by 2 is theta. And this is, well, that's it. Let's look at one more example. All right, here on this last example of looking at sum to product identities, we're asked to determine the exact value of sine 5 pi over 12 minus sine pi over 12. Sine 5 pi over 12 minus sine pi over 12. So when I look at my sum to product identities, I'm looking for the one that would be a subtraction with 2 sines. It's this one. So this is the identity that I'm going to use. So let me write it down. I'm going to use sine A minus sine B equals 2 times the sine of A minus B over 2 times the cosine of A plus B over 2. So I've just written down the identity. So for the sine of 5 pi over 12 minus the sine of pi over 12, again, it looks like A is 5 pi over 12 and B is pi over 12. So wherever I see an A, I'll toss in a 5 pi over 12. Wherever I see a B, I'll toss in a pi over 12. So that gives me a 2 sine 5 pi over 12 minus pi over 12, that's over 2, cosine 5 pi over 12 plus pi over 12. And again, that's over 2. Now just continuing and cleaning up, 5 pi over 12 minus pi over 12. Let's see, that's 4 pi over 12. 4 pi over 12 divided by 2. 4 pi over 12 divided by 2, that should be 2 pi over 12. 2 pi over 12 reduces down to pi over 6. So all of this junk here reduces down to pi over 6. Over here we have a 5 pi over 12 plus a pi over 12. Well, that's 6 pi over 12. 6 pi over 12 is pi over 2. So pi over 2 divided by 2, that's pi over 4. So we have cosine pi over 4. And now, it comes right back to the unit circle. The sine of pi over 6 is 1/2. The cosine of pi over 4 is square root 2 over 2. And if we multiply all this together, we get square root 2 over 2 as being the exact value of sine 5 pi over 12 minus sine pi over 12. And that's it for product to sum identities and sum to product identities.